Okay, we're going to continue chapter 8. So before our quiz, we were talking about how to prove triangles by angle-angle similarity. Today we'll look at side-side-side, side-angle-side similarity, which, here's the deal. If you kind of noticed, right, Burkeen, whenever we were doing angle-angle similarity, we still set up proportional sides, just like we did on all of our other stuff. So today's going to be the same idea, as long as you know that you have corresponding sides or side angle side, then you should be able to either prove that they are similar, or if it tells you they're similar, you can find missing parts. Okay, so let's start on the front page. Side similarity theorem says if the corresponding side lengths of two triangles are proportional. What does proportional mean? What is a proportion? How do we typically write a proportion? Yeah, so as a fraction. So if I set up three proportional fractions and then they are all equal, right? Then the triangles are the same, then the triangles are similar to each other. Okay? So on example 1, it asks us, are the triangles similar? Well, I need to set up my three proportional fractions, simplify, and see if they are equal. Fair enough? Who can tell me what two sides are the first two sides that you know would be proportional to each other?
48 and 8.
Okay, that'd be a great start. So 48 over 8. Okay, what would be my next pair of sides equal to each other?
84 and 12.
84 and 14, right? Because the second one is flipped. So 84 over 14. And then my last two, 72 over 12. Okay? Now, just as a reminder, right? Your calculator will do this really quickly if we don't know what each is divisible by. But what are 8 and 48 both divisible by? What are 8 and 48 both divisible by? 8, right? What's 48 divided by 8? 6 over 1. Okay? Anybody know what 18 and 14 are both divisible by? I'll give you a hint. It's on the bottom.
Why 18?
Sorry, 84.
14.
Yes, they're both divisible by 14, which gives you 6 over 1. Do you guys know how to type that in your calculator and get your answer?
Yeah.
Use the fraction button. It'll simplify it. Okay. Same thing. 72 and 12 are both divisible by 12, which gives you 6 over 1. So, are these two triangles similar to each other? Yeah. Yes. By side. Okay. So then we have to write our statement, right? So I'm going to switch colors just so it doesn't run together. Triangle. Let's say triangle ABC. And then who can tell me what triangle that would be similar to?
HGF.
Yeah, HGF. Good. Okay. Not too bad, right? We're just setting up our fractions, simplifying. We're good from there. Okay? All right. Same thing on example 2. Example 2 gives you triangle ABC, and it asks, is DEF or GHJ similar to the first one, right? So how many times are we going to have to check this? Twice, okay? So let's just start underneath DFE. Okay, now notice DFE has been flipped upside down from ABC, correct? Mm-hmm. So let's start here with 8. What corresponds with 8? 6, right? So 8 over 6. Okay, then what would correspond with 12? So 12 over 9. And then 16 over 12. Okay. What does 8 over 6 simplify to? 4 over 3. What about 12 ninths? 4 over 3. And 16 over 12. Also 4 over 3. Okay, so we can say triangle ABC similar to what? DEF. Good. All right. Now, here is ABC drawn the same way as JHG. What has happened? It's flipped, right? Straight across. So what side does 8 match up with over here? 8. So 8 and 8 match up, right? So we would get 8 over 8. What side does 12 match up with? 10. So 12 over 10. Now, can we already tell this is going to be a no? Yes, we should be able to. 16 over 16. Okay. Now, 8 over 8 gives us 1. What does 12 over 10 simplify to? 6 over 5. And then 16 over 16 would also be 1, right? So all three are not equal. So JHG is not similar to ABC. Fair enough? Okay. Any questions on this one? Feeling okay with it? All right. Let's do side angle side. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then we can say the triangles are similar. Okay? So notice it said the lengths of the sides that include the angles. So on this first example, right, we know these two angles. Sorry, we can go and mark those because they're what type of angles? Vertical. Okay. Now, are these two sides included with that angle? Yes or no?
Yes.
Those two sides touch the angle?
Oh, no.
No, right? So, am I even concerned with anything about these two sides?
No.
No, right? All I have to do is look at the two sides, okay, here, set those up, and make sure they're proportional. Now, here's where you have to be careful. Can anyone tell me what side corresponds with 14?
48.
48? 49, right? It'd basically be like if this one flips over here. Because notice, this angle would have to stay in the same spot, all right? So 14 over 49 is our first one. And what would that have to be equal to? 8 over 28. All right? What does 14 over 49 simplify to? 2 over 7. What about 8 over 28?
2 over 7.
Also 2 over 7. Good. Okay, so we're going to say triangle. Let's go LVM. Similar to what? UVT. Good. Okay. By SAS. Now, on this second one, is there an angle that these two have in common?
Yeah.
What angle?
V.
V, right? So that we're not even going to worry about because we know it's the same. What I truthfully would do is I would draw out two triangles and kind of label those sides. So for my small triangle, what's that left side going to be? 4. I'm going to go and put V here so we know that's the angle it shares, and then 5. Or you could mark it like so. Okay? Then for my big triangle, what's going to be that left side length? 12. Why? Yeah, because remember 8 is only the length from Y to W. So 12 and 15. Okay? So we did see this a couple times, like earlier this week, right? Where we have to combine the two together. Now we can set up our fractions and check and see. So 4 goes over 12 and 5 over 15. right? What does 4/12 simplify to? 1/3. And what about 5/15? Also 1/3. Okay, and we already decided that V was congruent to itself. So let's say triangle WVX, this one should be a little easier, similar to what? YVZ. By side, angle, side. Okay, all right, let's look at just a few on the back real quick, and then I'll let you go. So it says triangle ABC has the side lengths shown. The shortest side of a triangle that is similar is 15 units long. So what we're going to do is we're going to draw a triangle that is similar to the one shown, okay? As similar as you can make it. So just draw a triangle right next to it. If it doesn't look exactly the same, it's okay. We're going to pretend it is. All right? So the shortest side of the triangle we just drew is how many units? 15. Where should I label that at? Yeah, to match up where 6 is, okay? It says find the other lengths of the triangle. So what should we call this side on the left? X. What do we want to call the right?
Y.
Perfect. X and Y. You can label it whatever you want. Doesn't really matter as long as we find those two sides. Anyone have thoughts how we could do this?
6/15.
Okay,
9/6, right?
good. Right? Everything that we did 8,000 times this week and on our quiz yesterday. Okay? So we cross multiply. We get 6x is equal to 135. So x equals 22.5. Okay? What about setting up to solve for y?
6/15 equals 7/y.
Good. Right? Same idea. We cross multiply. We get 6y equals 105. So y is equal to 17.5. Really, most of us did really well on this stuff on our quiz. It was the back page that caused us a lot of problems, which I was kind of surprised by.
What was the back page?
Scale factor and area ratio,
Oh, yeah, I forgot which one. From
which we'll talk about. Okay, let me finish this. No, we'll talk about. Okay. Oh yeah, I noticed. Some of us forgot the difference between perimeter and area. Yeah. So. Okay. All right. Let's finish these two and then we'll talk about that for a second. Okay. All right. It says find the value of x that would make triangle ABC similar to triangle ADE. Okay. Now, again, here's what I would probably do, right? I would probably draw my small triangle here, which has a side of 7 and 7. And then I would draw the little bit bigger triangle. What side matches up on the left? 12, right? And then X. Anytime we have these triangles with like one inside of another, I would draw them out separately, label them, and then I think that'll save us from making mistakes. So, what's my proportion I'm setting up here?
7/12, 7/12.
Good. Okay,
7x equals 84.
good. 7x is equal to 84, so x is equal to 12. Honestly, you guys, it's the other nice thing I think that you get in this chapter is pretty much everything we're solving, we're doing the same way. Fair? Right? Other than scale factor and ratio of area. Okay? All right. Anybody have thoughts on our last one?
It's gonna be x/12. Right. And then it's gonna be
Draw the triangle first.
it'd be 6/12.
Oops.
Do the triangle first.
Okay. All right. I know, Turner. I know where you're at, but okay. Somebody first label the bigger triangle for me. What would be that base of the bigger triangle? 24. What's the height of the big triangle? 12. Okay. What's the base of my small triangle? And then the height?
Is it half? Is it 6? Just X?
Okay, so listen. If I know this whole part, right? Well, here's what you have to be careful for, because it's asking you to find this, right? SB, which is X. Okay, I agree. Like, we can call that X, but then we need the length from B to U. So if the whole thing's 12 and this is X, how could I find this missing part? 12 minus X is correct. Good. Okay. And this is why we show the example, because a lot of times we go straight to thinking like, oh, well, this is what I need, so I'm just going to label it X. But that's not what it asked us for, right? It asked us for the part above. Okay. All right. Somebody set those up for me.
24 over 6 equals 12 over 12 minus
Equals what?
12
Oh,
over
yeah, I'm with you. Okay. So we get 24 times 12 minus X is equal to 72. What do I get when I distribute 24? We need 288.
Minus 24.
Good. Minus 24x is equal to 72. Right? We subtract 288 from both sides.
you get 2.
Negative 260.
Good. Okay. So we divide by negative 24, and our x value is 9. Good. Okay. Truthfully, that would be the most difficult one we've seen. But we just have to pay attention to what we're labeling. Okay? All right. We are out of the book today.